Astra's rocket Karma has a little bit of a problem right now. You see, it's a bit overweight. We're now going to weigh the bronze retainer ring.
So the current here was too small. The voice was too loud.
Coming in at 1,281 grams. Because of our primary goal of just trying to get stuff to work, we've kind of overlooked the mass problem for the rocket, and she's coming in a bit heavy. Of course, this is a problem for a rocket because if you have too much mass, you don't have enough thrust to get off the ground. So now we have to turn to some other solutions for how we can save some of that mass. And one of the places that we've turned to is the retainer ring, which looks like this. It's basically the device that we're using that will hold the nozzle in place and keep it attached to our combustion chamber. Now, our initial design for this structure is quite simple. It's basically just an aluminum block, which has a little bit of lathing in the center to align it with the curve of the nozzle. But other than that, it's a fairly simple piece to make. But it turns out that from a structural perspective, there might be some room for improvement. And this is what led us to the world of topology optimization. Let me hand over to Atharva, who's the expert of topology optimization in our group.
Topology optimization is a technique of minimizing the mass of a solid component without reducing its structural integrity. So we use the Altair Inspire to run an optimization simulation, and here are the results. So it started with opening the file which I had created in another software. As you can see, it is entirely solid and it has a lot of mass. I wanted to optimize this surface. There is excess mass here. Creating an optimized part in Inspire is quite easy. I only needed to add the force and the support for creating a successful topologically optimized part. So I went to the structures tab, and in here I could find the supports which are applied to this circular surface, which is going to be supported by the combustion chamber of the rocket. Then I went to the pressure and applied the pressure force over the top of this surface. It is going to be pressurized due to the fluid pressure of the combustion fluids. After applying the support and the pressure force, I went to the optimize option and started optimization. Then I selected the minimize mass option here. I gave it my required safety factor. I gave it some constraints and then just pressed on run. That gave me this beautiful optimized part. As you can see here, it has created supports only where more stress is generated and rest of the geometry is hollow. Inspire creates these amazing three-dimensional curves which support the structure only at the places where maximum stress is generated. This is the beauty of topology optimization models, which creates these amazing structures and removes all the unnecessary material, keeping mass at a minimum.
As you can see, with this technique, we're able to get our mass of this ring all the way down to around 600 grams. That saves nearly a kilogram of mass off of this initial design. Now, a kilogram may not seem like much, but for Karma, that's like 2% of its dry mass, and every kilogram counts. If we use this same technique on some other structures on the rocket, we may be able to save even more mass. So if you have an application where you're trying to minimize mass, checking out Altair's topology optimization software is not a bad idea. And remember, to expand your horizons.